Today we're going to review some vocabulary having to do with some functions. The whole thing that we're looking at is we're going to look at what type of relation they are. Are they a function? And then we're going to figure out what the domain and range are. So one type of relation are ordered pairs. A lot of times I like to take a look and figure out the domain and range right away. And if we think back, domain, remember, is our x values. And we always want to write them when they're ordered pairs from least to greatest. So as we look at this, we have a -6, a -1, a 3, and a 5. Our range are always our y values. So if we write those out, we have -9. It's actually repeated twice. And then -1 is repeated twice, but we only list them once. In order for this to be a function, if you think back, we don't want to have any x values repeating itself. And when we looked at all the x values, none of them were repeating. So yes, it's a function. See if you can take a look at this second one. Write down the domain, the range, and then figure out if it's a function or not. You can pause the video while you do that. So you should get the domain to be -2, 0, 4. You don't repeat the -2 twice. Then the range would be -2, 0, 2, 3. Deciding if it's a function or not, it's not a function, because in our original, that x value of -2 is going to two different y values, so that's not a function. Another type of relation we can look at are mapping. Our domain are our x values, so that's 1, 2, 3, 4 in this case. Our range are the y values. If we determine if it's a function, remember, x values cannot go to multiple y values. And our 1, our 2, our 3, and a 4 do not go to multiple y values. So yes, it's a function. See if you can figure out the domain and range for the second one, and then if it's a function or not. So the domains are x values again, 1, 2, 4. Our range are the y values, 6, 9, 12, and 15. And then is it a function? No. And that's because this number 1 is going to two different y values. That number 1 in the domain is what screws it up. Another relation might be a table of values. Our domain are always our x values, so 0, 1, 2, 3, 4 in this case. Our range is our y values, 2, 4, 6, 8, 10. Is that a function? Do we have an x value repeating itself? We don't, so yes, it's a function. With the second one, Our x values are still our domain. The y values are the range. Is it a function? No. And what value screwed that up? That -2. Another relation we take a look at are actual graphs. And if you remember back, to know if it's a function, it has to pass the vertical line test. Meaning if you draw a vertical line through it at any point, it cannot hit the graph in 2 spots. So if we look at this first one, it is a function because we can't draw a vertical line in 2 different spots. The domain are our x values. So if we're looking all the way on the left here, that's at -5. This one is at -1. This one is at +2. And this one is at +4. Going from left to right, because smallest to biggest. Our range, that's our y values. So if we look at our lowest point, we're looking down at D here, which is -4. Then our next point is at -2. Next one is at 1. Last one is at 3. Looking at this graph, it also is a function because you can't hit 2 spots on there by drawing a vertical line. Our domain, because we have these arrows going all the way to the left, all the way to the right, and it's every single point in between. It's known as all real numbers, and the way we write that is from -infinity to +infinity. And we would do parentheses instead of a box bracket because it's saying it's approaching there. It continues on. Our range, we're looking at the lowest this graph goes and the highest it goes. It's the exact same. -infinity to +infinity. Maybe skipping to this one. Yes, it's a function because of the vertical line test. The domain, we're thinking, how far to the left does this graph go? Well, that arrow, yes, it's going down, but it keeps going all the way to the left as well, all the way to -infinity. Over here on the right, yes, it's going down, but it's going all the way to the right eventually to +infinity. Our range, we're thinking the lowest value it hits, which is all the way down in -infinity, and then the highest it hits right up here at a y value of 8, and it stops there, so we do a box bracket. Another graph, it is not a function because if I draw in a vertical line, it can hit 2 spots on the graph. I can actually do that in multiple spots. The domain is going to be our x values. So the farthest left that this graph ever goes is right here because there's nothing over here of that graph. Farthest left is 0. This is meant to have arrows here saying that it continues all the way to the right. So it would go all the way to +infinity. The range, lowest point it goes, this arrow is pointing all the way down to negative infinity, and a top one is going all the way to positive infinity. Let's take a look at some other graphs and some other type of values. So for this one, we are going to have it's stopping right there. There are no arrows drawn in. The domain, so the farthest left that this goes is right at that point. And that value is -5. 1, 2, 3, 4, 5. It is hitting there, so it's a box bracket. What's the farthest right that it's going? 1, 2, 3, 4. One more would be 5. It's hitting there, so you have a box bracket. The range, you're thinking the lowest value right there, and it's your y value, so 1, 2, -3. And then the highest is at +1, 2, 3. Coincidence with numbers, but that happens sometimes. Maximum value, you're thinking the highest value that it ever hits, and it's always your y, and that's up at 3. Your minimum value is the lowest that it hit, right there at -3. Increasing intervals, you're thinking going from left to right, during what x values is it going up? So the two spots in this case are right there and right there. So what is this x value? 1, 2, -3, and then it's increasing all the way until it hits here at 0. For increasing and decreasing intervals, we always do parentheses. It also starts right here and increases to there. We put a U in between, like a union, and then it goes from 3 to 5. If we look at decreasing, it's going down right there and right there. So the x values, you're going from -5 to -3, but then also from 0 to 3. Our zeros, another word for that, are x-intercepts, and we could see it's hitting right here and right there. So it's hitting at -3, 0 and 1.5, 0. The y-intercept is when it hits the y-axis, and that's at 0, 3. F of -2, that's saying when x is -2, what is your y value? So when x is -2, it's hitting right there. Where is it hitting at? It's hitting at 1. What about when f of x is -1? So that's saying when the y value is -1. So that's right here. What is your x value? at x equals 2. Take a look at the next one, pause the video, and fill it in. Can be a little tricky, but see what you get. You should be getting domain is from negative infinity to infinity. The range is the same from negative infinity to infinity. The increasing interval is from negative infinity to negative 1, and then also from 1 to infinity. Decreasing interval, it's not decreasing anywhere. Remember, you're going from left to right. Arrows don't make a difference. Left to right, is it going up or is it going down? Constant interval, that's when it's not going up or going down, and that's from negative 1 to 1. The zeros, or the x-intercepts, are negative 2, 0. The y-intercept is at 0, 1. At g of 2, you get 4. And then where g of x is equal to negative 2, it's at x equals negative 4. Hopefully you did fairly well on that. If not, make sure you ask me some questions.